So in our series of non-parametric tests, now we'll be talking about the Kruskal-Wallis test. It is a non-parametric alternative to a one-way between groups ANOVA. So as we all know that what we do on ANOVA is compare the means on dependent variable for different categories of some independent variable. So this particular Kruskal-Wallis test, since it is a non-parametric test and it is going to do the same job as an ANOVA does, it's just that it will now compare the scores, or I should say it converts those scores into some sort of ranks on some continuous variable. So definitely on the dependent variable, just like in ANOVA, you need a dependent variable which is continuous, and we will be doing so for an independent variable which is categorical, that is the one which will have some groups. So it allows you to compare more than two groups, so that is a good advantage of it. So we'll be looking at this data set where the data is having two variables, the group and the dependent variable, that is the gain variable. So basically this is the average, so this data contains the result of a small experiment regarding the brand creatine. So there is a brand which is a bodybuilding supplement, and this was given to a lot of people, say 15 people, and then the weight gain was observed. So why do you really need a body supplement? Is that you want to gain some weight. So after giving them the supplements, the different weight gains were observed, and these particular people, these 15 people, were actually divided into three groups. There was a group which did not take that particular supplement. There was other group which took this supplement in the evening time, and then there were another group that took this particular supplement in the morning time. So this particular experiment was being done for a month, and then after a month their weight gain was observed for each of these three groups: one which did not take it, one which took for the evening time, and one which took in the morning time. Then their weight gains were observed, and now the question arises, does the average weight gain depend on the creatine condition to which people were assigned? Creatine is the name of that supplement. So does the weight gain really depend upon the condition in which this particular supplement was assigned? So that is our question, which we'll be answering through the Kruskal-Wallis test. So we'll be testing that the three means, that is the three means or mean calculated for each of the three groups, are equal or not. So the most likely test you would come across is an ANOVA, correct? So this looks like a classic example of one-way ANOVA. But if you really happen to use it, you need to know that you require, or ANOVA requires, that the data follows certain assumptions. That is the assumption of normality, the assumption of homogeneity of variances, and that clearly does not get followed in our case. So to do this particular test, we go to Analyze, Non-Parametric Tests, Legacy Dialogues, and then since we're talking about some groups, so there is one assumption that the groups are independent. So we choose K independent samples, and then in the test variable, you pass on the continuous dependent variable whose mean you have to evaluate across groups. So that is the weight gain over the last month. Grouping variable is, so as you can see, the grouping variable was here, treatment group. Once you put it here, then it asks you to define the range. So you know that the range is minimum is 1, maximum is 3. So you put 1 here, 3 over here, and continue. Exact, 5 minutes, options, descriptives, continue, Kruskal-Wallis H, and then click OK. So once you have done it, you would be able to get this output. So the first table is of descriptive stats, which just tells you the descriptive of both the variables. This is less intuitive. You can just have a look at it, that the minimum weight gain was this much, maximum was this much, the mean weight gain was 562, and so on. And then we talk about finally the working of the Kruskal-Wallis test. As I said, this is going to work out some ranks. As against the means in ANOVA, it works out some mean rank. And you can see that the mean rank for all three groups, the mean rank of the variable weight gain for all three groups is this. So no creatine group, that is people who did not take this supplement, had the mean rank of 6.4. The ones who took it in the morning had the mean of 6.83. Evening ones had a higher mean, that is 11.75. On the face of it, you can see that these two groups are somewhat similar, and evening one is a little different. But from here itself, I can't really say that what statistics has to do or what statistics has to prove in the test. So the null hypothesis for our Kruskal-Wallis test is that the average mean weight gains in all three groups are equal, and the alternative is that they're not equal. So now you come onto this final test and you look at the p-value, that is the exact significance, 0.4146. Since 0.146 is way higher than alpha of 0.05, you're not able to reject the null hypothesis. That means the differences in the mean weight gains are not statistically different. Okay, so basically, significant. So there is no statistically significant difference between the mean weight gains across these three groups. So we can say that the study did not demonstrate any effect from the creatine condition, that is the body supplement condition, whatsoever it is, whether the person is given in the morning, evening, or maybe the person is not given at all. So thank you for watching the video.